Okay, so in this lesson, we're going to solve radical equations, and a radical equation has radicals in it. In this case, we have this radical equation, and we're taking a square root. So it could be a square root, it could be a cube root, fourth root, fifth root, and so on. In this lesson, though, in this course, we're only going to be interested in radical equations that have an index of 2. So remember the index of 2 right here. There's no number there. It's understood to be a 2. So we're only going to be interested in square roots in this lesson. Okay, but keep in mind this is called a radical equation. It's an equation because there's an equal sign. It's a radical equation because it contains a radical, namely in this case the square root. And what we're going to try and do is solve this radical equation. All right, now to solve a radical equation, we're going to use the power rule. I'm going to talk about the power rule in a little while. But to solve a radical equation, there are some steps you need to follow. So step 1 is to isolate one of the radicals on one side of the equation. So there are going to be situations where you're going to have a radical equation with more than one radical. So this radical equation has just one radical. So in a few minutes, we're going to solve a radical equation where there are 2 radicals in it. But the process is to get one of the radicals by itself. All right, so you want the radical on one side, the other terms on the other side. All right. Step 2, once you get step 1, once you get one of the radicals by itself, step 2 is where you're going to use that power rule. So basically it means this. You're going to raise each side of the equation to a power that's equal to the index of the radical. All right, so in this particular case, since the index is 2, you're going to raise both sides of the equation to the second power. So you're going to square both sides. If this was a cube root, you would raise both sides to the third power. If this was a fourth root, you'd raise both sides to the fourth power, and so on. Okay, now, so the first 2 steps, no issue. So you're going to get one of the radicals by itself, and then you're going to clear the radical. You're going to clear the radical by undoing the process. So right now I'm taking the square root. So the opposite of taking the square root is to square both sides. So hence the idea of that power rule. All right, now, if the equation still contains a radical, so that's where we have more than one radical. So the easy kind is where there's just one radical. It's a little bit more not difficult, but a little bit more work if you have more than one radical. But if there's still one radical, if there's still a radical left, you're going to repeat steps 1 and 2. If there's no radical left, then you can just solve the equation. You're going to see what we mean by that in a few minutes. Okay, now, step 4. Whenever you're solving a radical equation, and we're going to talk about the reason why, but whenever you're solving a radical equation, you must check your solutions. And you must check in the original equation. And we're going to talk about the situation why. So you must check this. So this must be done. Okay? All right. Now, let's talk about the power rule for a moment. So let's go here and talk about the power rule. Okay, now, if both sides of an equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. All right, so if both sides of an equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. So what we mean by that is this. So for example, we all know that if I ask you to solve x minus 2 equals 0, so we have this linear equation, okay? And to solve this linear equation, we would add 2 to both sides, and so you'd get x equal 2. Okay, so this equation this equation right here. Now remember, these are equivalent. So x minus 2 equals 0 is the same thing as this is equivalent equation of saying x equals 2, meaning that the solutions here are going to be the solutions here. That's all that means. But what I want to do is show you something. If I take this equation right here, this equation, x equals 2, and the solution to this equation is only 2, because it says x equals 2. But if I take this equation and I square both sides, and so I get x squared equals 4, okay? Now what this is saying is this: if you raise both sides of an equation to a power, the solution here is going to be among the solutions here, okay? And it is, okay? So watch. See, the solution here is x equals 2. The solution here, if you remember, this is linear, this is quadratic. So if you solve this, you're going to get x squared minus 4 equals 0, and then you factor. This is the difference of two squares, and you solve and use the zero factor property. So you get x minus 2 equals 0, x plus 2 equals 0. And so you get x equal 2 and x equal negative 2. So what this said is this, and I'm going to explain this again. If both sides of the equation, so I took this equation here, and the only solution to this equation is 2, because that's what it says, x equal 2. But if I raise both sides to a power, like I did here, I raised both sides to a power, so I got this new equation. What this is saying is that the solutions here will be among the solutions here. And it is, because look, x equals 2, and we got the solution x equals 2 here. Okay? All right, so keep that in mind for right now. We're going to go further with this discussion. This property does not say that raising both sides of an equation to a power yields an equivalent equation. So remember right here, these two equations are equivalent. The solution to this equation is the same as the solutions to this equation. So those are equivalent. This equation right here is not equivalent to this equation. This equation is not equivalent to this equation because the solutions are not identical. The solution here is 2, but the solution here, there are 2 of them. It's 2 and negative 2, so they're not equivalent. So remember, equivalent equations have the same solutions. All right, so let's talk about this again. This property does not say that raising both sides of an equation to a power yields an equivalent equation. So that's what this means. Let's continue. A solution of the new equation may or may not be a solution of the original. So let's go back over here. So you see this new equation? The solutions are 2 and negative 2. Are the solutions here solutions to the original? No. One of them is, but the other one is not. All right, so that's what this is saying. The solutions of the new equation may or may not be solutions to the original. Keeping that in mind now, let's look at the other one. Therefore, each solution of the new equation must be checked to make sure it is a solution to the original equation. So that's why when we did step 4, all proposed solutions, so see this right here would be proposed solutions. So all proposed solutions must be checked in the original equation. And remember, you only do that if you're raising both sides to a power. So far, we haven't done that. We haven't raised both sides to a power. Now we are. So we're solving these radical equations. Okay, now one other thing. Let's talk about extraneous solution. We talked about this word before, but remember, an extraneous solution is a proposed solution that is not a solution to the original equation. All right, so an extraneous solution is a proposed solution that is not a solution to the original. So if we're going to use this example here where we had this equation and I raised both sides to a power, so I squared both sides. 2 is a solution to the original, but negative 2 is not, because negative 2 does not equal 2. So this would be called an extraneous solution right here. So it's kind of like a false solution. So that would be called your extraneous solution. Okay? All right, so it's not that difficult. It's fairly simple. So let's go ahead and start solving some radical equations. Now remember, in this lesson, we're only going to be dealing with square roots. So we're not going to do cube roots, we're not going to do fourth roots, and so on. You're going to do that in the next course, but in this lesson, we're only going to be interested in radical equations that have an index of 2, so square roots. Okay, so let's solve these equations. So we're going to solve these radical equations. All right, so number 1, let's suppose we had this. Suppose we had the square root of 2x is equal to 4. Square root of 2x equals 4. So we have this radical equation. Step 1 says we need to make sure that, remember, to solve this radical equation, you're trying to get x by itself. You're trying to solve for x. So you need to somehow get rid of this square root. And remember, the opposite of taking a square root is to square both sides. All right, so the opposite of square rooting is squaring. The opposite of cube rooting is cubing, and so on. So, but remember your steps. So step 1 is to isolate one of the radicals on one side. Well, in this case, it already is. So it's already, step 1 has already been done. The square root's already by itself. Okay, now step 2 says this. All right, so look at your index. My index is 2, square root 2. So step 2 says, now we're going to raise both sides to a power equal to the index. So in other words, if my index is 2, then I'm going to square both sides. So in other words, I'm going to get this. So I'm going to square both sides, just like that. Okay? Now remember this. Now there's several things you have to remember. So you see this right here, this left side, so we raise both sides to an equation of the equation equal to the power of the index, and we're going to simplify. All right, so simplifying means that on the left side you have the square root of 2x squared, which means square root of 2x and square root of 2x. But remember, the square root of 2x times the square root of 2x is just 2x. All right, so you can also think of it like this. So whenever you are multiplying radicals and they have the same index, you multiply the radicands. 2x times 2x is 4x squared. And so you have the square root of 4 times the square root of x squared. The square root of 4 is 2, and the square root of x squared is just x. And so that's what this is. But also we talked about the fact that in a previous lesson that whenever you square a square root, the square and the square root, those are inverse properties, so they kind of undo each other, and so you're just left with the radicand. So my radicand is 2x. Now we're going to go ahead and simplify the right-hand side. 4 squared is 4 times 4, which is 16. All right, so notice I went from this radical equation to a linear equation. And so step 3 says, all right, so step 3 says if the equation still contains a radical, you repeat steps 1 and 2. Well, it doesn't. I don't see a radical anymore. If not, then solve the equation. Okay, so let's solve the equation. So again, remember I went from a radical equation to a linear to solve this linear equation. You've been dealing with linear equations for a while now. We're just going to get the variable by itself. So right now, multiplying x by 2, the opposite of multiplying by 2 is to divide by 2. And so 2 divided by 2 is 1. 1 times x is x. I get x to be 8. All right, now that's my proposed solution. So remember, I raised both sides to a power. So I've got to check this proposed solution. Check in the original. So you must check. So that's where step 4 comes into play. You must check. And always go back to the original. So here's my original equation. And I'm going to, wherever I see the variable x, I'm going to substitute 8. I get the square root of 2 times 8, and I want to see if that's equal to 4. That's the question. So 2 times 8 is 16, and so the question is the square root of 16 equal to 4, and the answer is yes. So this is a solution. Okay, so that's your solution. All right, but remember, whenever you raise both sides to a power, you must check your proposed solution. And because if it's not a solution to the original, then that would be an extraneous solution. All right. Let's look at number 2. So number 2, let's suppose we had this, the square root of x plus 5 is equal to, let's say, 2. Square root of x plus 5 equal 2. So again, let's go through the steps. So step 1, we have this radical equation. My index is 2. The radical is by itself. So step 2 says that I'm going to raise both sides to a power equal to the index. So if my index is 2, then I'm going to square both sides. So in other words, I'm going to get something that looks like this. So you're going to square both sides. All right? And then remember the square and the square root, if you go through this process again, but the square and the square root, those two are inverse properties, so they undo each other. And so you get x plus 5. So remember, you're simplifying each side now. So this side simplified is just x plus 5. This side simplified is 4. And so again, notice I went from this radical equation to a linear equation. So step 3 is to solve this linear equation. I'm going to subtract 5 from both sides. And so I get x to be -1. Okay? So again, this is my proposed solution. But since I raised both sides to a power, I've got to check my proposed solution. So let's check this. You must check. And always go back to the original. So here's your original equation. And wherever I see the variable x, I'm going to substitute -1. So I get the square root of -1 plus 5. And I want to see if that's going to equal 2. Well, -1 plus 5 is 4. And the question is the square root of 4 equal to 2? And the answer is yes, because the square root of 4 is 2. All right, so that's your solution. All right, number 3. So it's not difficult at this point. It's fairly simple. Solving a radical equation, you just got to make sure you check your proposed solutions. Okay, number 3, let's suppose you had the square root of 3x plus 1 is equal to, let's say, 4. Square root of 3x plus 1 equal 4. Okay, so I have this radical equation. The radical is by itself. So you're going to raise both sides to a power equal to this index. So you want to get rid of the square root so you can solve for x. So you're going to square both sides in this case. Remember, in this lesson, we're only dealing with square roots. And so if I square both sides, just like this, and I simplify now, the square and the square root undo each other, so you're left with the radicand. So I'm left with 3x plus 1. Equal, and then 4 squared, 4 times 4 is 16, so I went from this radical equation to a linear equation. So I'm going to solve this linear equation. So I'm going to subtract 1 from both sides. I get 3x equal 15. Divide both sides by 3. I get x to be 5. All right, so that's my proposed solution. But again, since I raised both sides to a power, I must check the proposed solution in the original. So if I check, go back to the original now. So square root of 3x plus 1, I want to see if that's going to equal 4 when I substitute 5 for x. So let's see what we get. 3 times 5 plus 1, I want to see if that's going to equal 4. That's what you got to check for. Well, 3 plus 5 is 15. 15 plus 1 is 16. So I got the square root of 16. And the question is that equal to 4? And the answer is yes. Square root of 16 is 4. 4 equals 4. So this is your solution. So this proposed solution is a solution to the original. Okay, number 4. All right, number 4, let's suppose we had the square root of 3x is equal to -2. The square root of 3x is equal to -2. All right, now, I have the radical by itself. So I'm going to, and this is a square root, so I'm going to square both sides. So I'll go ahead and square both sides. And remember, be careful. You gotta make sure you put. Notice in each of these situations, I've been enclosing each of the sides in parentheses. So again, notice I enclosed the square root of 3x in parentheses and a enclosed -2 in parentheses. And I'm going to square both sides. All right, so be careful. Make sure you're doing this just like this. Okay, now I'm going to simplify each side. So the square and the square root undo each other. So I'm left with the radicand, 3x. Over here, a -2 squared means a -2 times a -2, which is a 4. And then to solve for x, now remember I went from a radical equation to a linear, so I'm going to divide both sides by 3. And so I get x to be 4/3. Okay? So, now remember, this is a proposed solution. So this solution, just to make sure you're aware of this, this solution, this proposed solution is a solution to this equation here. But the question is, it's a solution to this equation, all right, which is a solution to this equation. But the question is that a solution to the original? So that's what we got to check. All right, so let's check. So when I check this, go back to the original, I get the square root of 3x equal -2. So where we see the variable x, I'm going to substitute 4/3. So here's what we get. We get the square root of 3 times 4/3 equal a -2. All right, well, remember, 3 times 4/3, 3 over 1 times 4/3, the 3's divide out, and you're just left with 4. So my radicand is just 4. So the square root of 4, and the question is that equal to a -2? Well, the square root of 4 is 2, and is 2 equal to -2? The answer is no. 2 does not equal -2. So this proposed solution, remember, that's called an extraneous solution now. This is an extraneous solution. That's called an extraneous solution. Okay? So it's a false solution. So this solution, what that means is this. This is a solution to this equation here, but it's not a solution to the original. So when you're asked, now this is going to be important, when you're asked to solve the square root of 3x equal 2, all right, and you say your answer, remember how we said x was equal to 5 here, and over here we said x was equal to -1, and then x equal 8. Over here, though, you have to say this. You have to either say, in the blank, you would either say no solution, or you can say the empty set, the symbol for the empty set. All right, so in my math lab, they would use this symbol for no solution. So you'd say no solution or the empty set. Don't say in the blank extraneous solution. That's not what we're looking for. You're solving this equation, so you either got to say x equal 5 or x equal -2/4 or things like that, or you have to say no solution or the empty set. All right, but the extraneous solution only implies that this was a solution to this equation here and the equation that we squared, but it's not a solution to the original. Okay, so now we're at a situation where when we raise both sides to a power, we can end up with the proposed solution being extraneous. And since this was the only proposed solution, and I checked it, and it wasn't a solution to the original, we had to say no solution. So this equation right here has no solution. Okay? All right, number 5. All right, number 5, let's suppose we had this. Let's suppose we had the square root of 4x minus 3 minus 5 equals 0. The square root of 4x minus 3 minus 5 equals 0. Okay, it's not that difficult. It's fairly simple to deal with. Just remember your steps. So step 1 says you have to get the radical by itself. All right, so before you raise both sides to a power, you need to get that radical by itself. Well, that's very simple to do. Just add 5 to both sides. So I get the square root of 4x minus 3 is equal to 5. Now it looks like all the previous 4 problems. So now it looks like, let's say, number 3. All right. So once you get the radical by itself, the next step is to raise both sides to a power equal to the index. So since my index is 2, and remember in this lesson we're only dealing with square roots, so you're going to be squaring both sides just like this, just like we've been doing. Now remember, the square and the square root undo each other. And so I get the radicand, which is 4x minus 3. And 5 times 5 is 25. So I simplified each side. Now notice I went from a radical equation to a linear equation. So let's solve this linear equation. So I'm going to add 3 to both sides. Combine like terms. I get 4x equal 28. Divide both sides by 4 to get the variable by itself. I get x equal 7. Now remember, this is a proposed solution. This is a solution to this linear equation, and it's a solution to this equation that I squared both sides of. But the question is it a solution to the original? Is it a solution to the original? Always go back to the original, because you could have made a mistake here. Always go back to the original. So let's check. So I'm going to rewrite the original over. Okay, now where we see the variable x, I'm going to substitute 7. So I get 4 times 7 minus 3. Whatever that is, I'm going to subtract 5. And the question is that going to be 0? That's the question. Well, 4 times 7 is 28. 28 minus 3 is 25. So the question is the square root of 25? Subtract 5. The same thing as 0. Well, the square root of 25 is 5. And 5 subtract 5 is 0. So that is true. So this is a solution. So that's your solution. So in the blank, you would say x equals 7. All right. So the solution, so in other words, the solution of the square root of 4x minus 3 minus 5 equals 0 is x equals 7. That's your solution. Okay. All right. So remember, you got to get the radical by itself, and everything else is just like we've been doing. Okay. Number 6. Suppose we had the square root of 2x minus 3 minus 2 equal 1. Same idea. So I'm doing another one just like we just did. So you're going to get the radical by itself. So you're going to add 2 to both sides. And then combine like terms. So I get the square root of 2x minus 3 is equal to 3. All right, and then remember the next step is to get rid of the square root. So you're going to raise both sides to a power equal to the index. So since I'm dealing with the square root here, my index is 2. I'm going to square both sides. So I get this. And then I'm going to simplify each side. The square and the square root undo each other. So you're left with the radicand, which is 2x minus 3. 3 squared is 9. So notice I went from this radical equation to a linear equation. So I'm going to solve this linear equation. So I'm going to add 3 to both sides. Combine like terms. I get 2x equal 12. And then divide both sides by 2. I get x to be 6. All right, so that's my proposed solution. So remember, this is a solution to this equation, to this linear equation, and to this equation that's being squared. But is it a solution to the original? That's what you got to find out. Now remember, always go back to the original. Don't go back to this one here, because you could have made a mistake. Just go back to the original. So let's check. I'm going to write the original. So here's my original. Okay. And where we see the variable x, I'm going to substitute 6. So I get the square root of 2 times 6 minus 3. Whatever that is, I'm going to subtract 2. And the question is the left side going to equal 1? That's a question. Well, 2 times 6 is 12. 12 minus 3 is 9. So this is the square root of 9. And this question is the square root of 9 subtract 2. The same thing as 1. Well, the square root of 9 is 3. 3 subtract 2 is 1. Okay? So the solution, so this proposed solution is a solution to the original. So that is a solution to the original. So the idea would be this now. So basically you're saying this: the solution of the square root of 2x minus 3 minus 2 equal 1 is x equals 6. So that's your solution. All right, so there's number 6. All right, let's look at number 7. Okay, now number 7. Suppose we had this. suppose we had the square root of square root of 13 minus x equal x minus 1. Square root of 13 minus x equal x minus 1. Okay, now, notice what's going to happen when we get to this point. So just be aware that whenever, if you go back to all these problems we did, all these problems, whenever we got to this point, we went from a radical equation to a linear, okay? And all the problems we've done, that's what happened. We went from a radical equation to a linear. And then we just solved this linear equation. So it's very simple to solve this linear equation. Okay, now, let's look at this one. Let's see what happens here. So, oh, and also remember that whenever we did the previous one, and it sometimes helps to know, to compare what we've done to this new, or to the equation looks a little bit different. And the reason it looks a little bit different is because when you notice all these 6 problems, the previous 6 problems, when we got the radical by itself, see when we got the radical by itself, the other side was just a real number. There was no variable on the other side. So you have the radical and then a real number. So if you go back, you'll notice that then in all the problems we've done, you had this radical and the other side was just a real number. Now, what you have is a radical by itself, but the other side also has a variable expression. It has a variable on the other side. So let's see what happens. So the process is going to be the same, except at some point you're gonna see that there's also a difference between going from a radical to a linear and then going from a radical to something that may not be a linear. Okay? So let's discuss this part. Okay, so the steps will be the same. Steps are the same. So step 1 is you're going to isolate the radical. The radical is already by itself. The radical is already by itself. So the next step is to raise both sides to a power equal to the index. So since I'm taking the square root of both sides, since this is the square root, I'm going to raise both sides to the second power, just like I've been doing. But remember, when we discussed the previous 6 problems, we did this. We enclosed each side in parentheses before we squared. All right, so that's going to be important. This part is always important. So we're going to enclose both sides in parentheses. Enclose both sides in parentheses. And now we're going to square both sides. That's important. So again, the square and the square root undo each other. So I'm going to have 13 minus x equal. All right, now here's the situation. So here I'm squaring x minus 1. So I got to simplify this. So let's talk about what that is. So notice that I'm squaring a binomial. So remember, x minus 1 squared means x minus 1 times x minus 1. So I'm going to use a FOIL method. X times x is x squared. The outer is a negative x. The inner is a negative x as well. And the last, a negative 1 times a negative 1 is a positive 1. Combined like terms, I get x squared minus 2x is a negative 1x, and a negative 1x is a negative 2x, and then plus 1. So this left side, this right side right here, when I simplify this, when I square x minus 1, I get this quadratic trinomial right here, this quadratic expression. So I get x squared minus 2x plus 1. All right, so now we're at a situation where we're squaring a binomial, and we're going to get this quadratic trinomial. So it looks like this. So notice that in the previous problems, again, compare what you've been doing to what we now have. In the previous problems, I went from a radical equation to a linear equation. This is linear. Here, I'm going from a radical equation to a quadratic equation. Now we're going to solve this quadratic equation. So let's see what happens when I solve this quadratic equation. Okay, so remember, to solve a quadratic equation, you're going to put it in standard form. Remember the idea of standard form. So then you're going to factor or use the quadratic formula. But these in here will be factorable. So just go ahead and factor, or if you having a little bit difficulty factoring, just use quadratic formula. But we're going to just go ahead and factor here. Okay, so since the x squared, since the squared term is on the right side and it's positive, see positive 1, I'm just going to bring all these other terms here. So I'm going to add x to both sides, and notice I'm aligning my like terms. I'm aligning my like terms. So remember, right now I'm subtracting x. The opposite is to add x. So remember, what I'm doing now is solving this quadratic equation. Solving a linear equation was much easier. Solving a linear equation was much easier. Solving a quadratic equation is a little bit more work. And then combine like terms, I get 13, this is 0 right here, equal x squared. A negative 2x and a positive 1x is a negative 1x, and then plus 1. Subtract 13 from both sides. Notice I'm aligning my like terms. So I'm putting the constants under each other. 13 minus 13 is 0, equal x squared minus x, and then a positive 1 and a negative 13 is a negative 12. All right, so I have this quadratic equation. Now I'm just going to go ahead and transpose each side. So I'm going to put 0 on the other side. So I get x squared minus x minus 12 equals 0. So again, notice I went from this quadratic equation to I went from a radical equation to a quadratic equation. I'm solving this quadratic equation. So now this quadratic equation is in standard form. And I put in descending order, standard form. So I'm going to factor. So remember, the ones that we're going to do here will be factorable. The one in your test or final will be factorable as well. Okay, so I'm going to factor. So let's say I get x times x is x squared. I need the product to be a negative 12 for the last term, and I need the out and the inner to combine to be a negative 1x. And the only way that can be possible is if you say x minus 4 times x plus 3. Oops, x plus 3. And always check. X times x is x squared. The outer is a positive 3x. The inner is a negative 4x. And when I add them up, when I add the out and the inner, I do get a negative x. And a negative 4 times a positive 3 is a negative 12. Okay, so remember what we did next. Once you factor, you solve this quadratic equation. Once you factor, you're going to set each factor equal to 0. So that's the zero factor property. So I get x minus 4 equals 0, x plus 3 equals 0. And notice I went from this quadratic equation to two linear equations. And so I get x to be 4 and x to be negative 3. Okay, now remember, these are your proposed solutions. So in other words, those are solutions to this quadratic equation, but it may not be a solution to the original. So remember, these solutions to the original are among the solutions here, but it's not the same way around. So the solutions here are not necessarily the solutions to the original. So that's why you have to check. Okay, so you got to check these two now. So remember, in the previous problems, when you solve this linear equation, there's only one proposed solution. Here, remember, when you solve a quadratic equation, most of the time you had two solutions. So now you have two proposed solutions to check. All right, so let's check each one. So let's check x equal 4 first. So notice you got to check both of them now. So let's check x equal 4. So go back to the original. I'm going to write the original over. So here's my original. 13 minus x, the square root of 13 minus x, equal x minus 1. So wherever we see the variable x, I'm going to substitute 4. So I get the square root of 13 minus 4. And I want to see if that's going to equal 4 minus 1. That's a question. So wherever we saw the variable x, I substituted 4. Well, 13 minus 4 is 9. So the square root of 9. 4 minus 4 is 3, and the question is this side equal to this side? And the answer is yes, because 3 does equal 3. So this proposed solution is a solution to the original. Now let's check the x equal negative 3. All right, and so it's a little bit more work. It's a little bit more work when you go from a radical to a quadratic. So let's check x equal negative 3. So I check x equal negative 3. Again, I'm just going to write the original equation over. So I get the square root of 13 subtract, and be careful, you're subtracting now. So 13 subtract a negative 3. And I want to see if that's going to equal negative 3 subtract 1. Well, 13 subtracting negative 3 means 13 plus 3, which is the square root of 16. And then, remember, we want to see if those two sides are equal. And a negative 3 and a negative 1 is a negative 4. Well, the square root of 16, remember this is a positive square root of 16, so the square root of 16 is 4. And the question is 4 equal to a negative 4? And the answer is no. Okay? So, what that means is this negative 3, this proposed solution, negative 3, is a solution to this quadratic equation, but it's not a solution to the original. That's what that means. So, in other words, this solution right here, this right here, is an extraneous solution. So that's an extraneous solution. So in other words, it's a solution to this equation, but not a solution to the original. Okay, so how do you answer the question? How do you answer if it says solve this equation? So basically, you're going to say this. You're going to say, okay, so if it says 13, the square root of 13 minus x equal x minus 1, and in the blank, so you have all this work, in the blank, you're just going to put x equal 4. That's the only solution. That's your solution. So that's what you write. Okay, so now be careful. Let me just kind of explain something. So remember a while ago, in one of the problems we did, if I can find it, we had no solution here. All right, now that's the reason is because, remember, we went from a radical equation to a linear equation, and there was only one proposed solution, and that proposed solution was not a solution to the original. So there was nothing else to check. So there's no other solution. There's no solution. So you say no solution, or the empty set. But here, I went from a radical equation to a quadratic, and I had two proposed solutions. One of them was extraneous, and the other one worked. So the only solution to the original, the only solution to this quadratic equation, this radical equation, is x equal 4. So that's what you write, x equal 4. Okay? So notice how this thing works. Don't put x equal 4 and then say x equal negative 3, which is extraneous. You only want the solution here. So the solution is this. This is not a solution to the original problem. Okay? All right. So just keep that in mind. Okay, so now let's look at this example. Okay, it'll be example number 8. And let's suppose we had this. Suppose we had x minus the square root of 4 minus 3x equal negative 8. So x minus the square root of 4 minus 3x equal negative 8. Okay. Now, remember step 1 is to get the radical by itself. That was step 1. Get the radical by itself. What I'm going to do here is this. Notice that this radical, see where the coefficient of this radical right here is a negative 1. I'm going to go ahead and bring this radical to the other side. I'm going to bring this constant to this side. And you're going to see why. So that way, if I bring this radical to this side, it's no longer a negative square root, it becomes a positive square root. Okay? So basically, I'm going to add the square root of 4 minus 3x to both sides. So make sure you, on the My Math Lab, there's an example like this. So make sure you do it like this. So you're going to add the square root of 4 minus 3x to both sides. And when you combine like terms, the negative square root of 4 minus 3x and a positive square root of 4 minus 3x is 0. So I get x equal negative 8 plus the square root of 4 minus 3x. Now I'm going to add 8 to both sides. And so I get x plus 8 when I simplify each side. This is 0, and I'm left with the square root of 4 minus 3x. Okay? All right. So notice I went from this radical equation to this radical equation. They're equivalent. Those equations are equivalent. I haven't raised both sides to a power yet, so they're equivalent. All right. So in all the problems we've done, and just compare what we've done. So in all the problems we've done, when we got the radical by itself, it was a positive square root that we had by itself. And so that's what I was trying to do. I was trying to get this, so I didn't want to subtract x from both sides because then there would be too many negative terms. So I just wanted the radical to be positive. So since it was negative here, I just brought it to the other side. Okay? And so that's what we got. So again, though, make sure all these steps are correct. Make sure you're careful with all these steps. Okay, now I'm going to, the radical is by itself. The index is 2, so now I'm going to square both sides. So remember, though, what you're going to do is you're going to enclose each side in parentheses. And now you're going to square. All right, so now we have x plus 8 squared. So we have x plus 8 squared. So we got to simplify this side. So x plus 8 times itself. So I'm going to use a FOIL method. The first, outer, inner, last. So x times x is x squared. The outer, x times 8 is 8x. The inner, 8 times 8 is 8x. And the last, 8 times 8 is a positive 64. Combine like terms, I get x squared plus 16x plus 64. Okay? So that's this left side right here. So this left side, when I square this linear expression, I get this quadratic expression. So I get x squared plus 16x plus 64 equal. Over here, remember the square and the square root undo each other. So those are inverse operations. So you're left with the radicand, which is 4 minus 3x. And now you can do just like you've been doing, just like we did the previous problem. Right here, let's see where we were. Okay, so right here, so that's where you put it in standard form. So you did all this work to get it in standard form. And then what you got in standard form, you factored. All right, so I'm going to add 3x to both sides. I'm trying to get this in standard form. And so I get x squared plus 19x plus 64 equal. When I simplify this side, I'm just left with 4. I'm going to subtract 4 from both sides. Notice I'm aligning my like terms. It does help if you do that. Then I'm going to simplify each side. I'm going to combine like terms. I get x squared plus 19x plus 60 equal 0. Okay? All right, now we're now going to factor, so it's a quadratic equation. So you can use the quadratic formula, but the ones in this lesson are factorable. So we're just going to go ahead and factor. And so I get x times x is x squared. Now we got to figure out, now remember, whenever the coefficient of x squared is 1, it's very simple to deal with. It's very simple to factor. So you want to find two numbers whose product is a positive 60 and whose sum is a positive 19. And so if you say, well, what about 2 times 30? Well, 2 times 30 is 60, but the sum is 32 and it's not 19. All right, so keep those things in mind. So what's going to work, though, I think will be x plus 4. So 4 times, let's see, I don't have my calculator with me, so I'm going to have to do this the long way. That's 4, so 15, and that should work. All right, because notice, the outer is 15x, the inner is 4x, and when I combine them, I get 19x, and then 4 times 15 is 60. All right, so I factored this quadratic equation, and so I'm going to use the zero factor property. So I'm going to set each factor equal to 0. And so notice I went from this quadratic equation. Well, first of all, keep in mind I went from this radical equation to a quadratic equation, and then I'm just putting this quadratic equation in standard form. You either factor, if it's not factorable, use quadratic formula, or you can use a quadratic formula to begin with. But these are going to be factorable in this lesson. And so I went from this quadratic equation now to two linear equations. So I get x equal -4 as a proposed solution to the original. And I also get x equal -15 as a proposed solution to the original. So these are proposed solutions. So these are solutions to this quadratic, but they may not be solutions to the original. So we're going to call them proposed solutions for right now. I'm sorry, this should be, -4, -15. Okay, so let's check each one. So let's check this one first. So let's check x equal negative 4. So you go back to the original. Remember, the original was this, x minus the square root of 4 minus 3x equal negative 8. Remember, always go back to the original. All right, so you got to be careful with this because you're dealing with negative proposed solutions. So I get x, which is negative 4, subtract the square root of 4 minus 3 times a negative 4, and I want to see if that's going to equal a negative 8. All right, so let's simplify this right again right here. Now be careful. This is 4 subtract 3 times a negative 4, which means the same thing as 4 plus a negative 3 times a negative 4. So a negative 3 times a negative 4 is 12, positive 12. 12 plus 4 is 16. So here's what I get. I get negative 4, subtract the square root of 16, and I want to see if that's going to equal negative 8. Well, the square root of 16 is 4, so this becomes negative 4 minus 4, and I want to see if that's equal to negative 8. Well, a negative 4 and a negative 4 is a negative 8, and so they do equal. Okay, so this is going to be a solution. That's a solution. All right, now when I say solution, I mean it's a solution to the original. That's what I mean. So it's definitely a solution to this quadratic. We know that for sure. But is this proposed solution a solution to the original? That's the question, and it is. We checked it. All right, let's do the other one. So we're going to check, let's do the next page. So now we're going to check x equal negative 15. Again, go back into the original. You're going to drag the original equation over. So x minus the square root of 4 minus 3x equal negative 8. That was the original equation. And wherever we see the variable x, I'm going to substitute negative 15 this time. So I get negative 15, subtract the square root of 4 minus 3 times a negative 15. And I want to see that's going to equal negative 8. All right, so just like we've been doing, a negative 3 times a negative 15 is a positive 45. A positive 45 and a positive 4 is a positive 49. So I get minus 15 minus the square root of 49, and the question is that going to equal negative 8? Well, square root of 49 is 7, so this becomes negative 15 minus 7, and is that equal to negative 8? Well, a negative 15 and a negative 7 is a negative 22, and those do not equal. So what that means is that negative 15, this proposed solution, although it is a solution to this quadratic, it is not a solution to the original. So it's not a solution to this radical. So this right here is technically an extraneous solution. Okay, so I was talking about extraneous solution. It's a solution to this equation, but not the original. All right, now the question is, what do you put in the blank? Well, in the blank, where it says where the answer is going to be, you write down what the solution is. There's only one solution. It's negative 4. So you say x equal negative 4. That's your solution. That's the only solution. All right, don't put anything. Don't put negative 15 and say it's extraneous. You only want to state what the solutions are. The solution is only x equal negative 4. Okay? All right, so that is going to take care of this lesson. So again, in this lesson, we dealt with radical equations, and it does help if you know your steps. Okay, just know the steps, and it's very simple. So when you solve the radical equation, and you raise both sides to a power, you're going to either, in this lesson, you can either end up with a linear equation or a quadratic equation. Okay, so it's not a difficult lesson. Just go back over these, and it's pretty straightforward.